Hi guys, welcome to my channel once again. So today we will be discussing about the topic trigonometric identities. So in our last session we have discussed about the problems related to the complementary angles of trigonometric ratios. So today we will be discussing about the trigonometric identities. So we all know there are three identities, right? Now before the identities, letting you know the identities, so let us derive the identities. Okay, now consider a right angle triangle. Okay, so we shall name it as A, B and C. Okay, so we shall name it as A, B and C. Now in this right angle triangle, according to the Pythagoras theorem, so what can we write, guys? So the Pythagoras theorem states AC square is equals to AB square plus BC square. Correct? So this is what the Pythagoras theorem states. I will name this equation as 1. Equation number 1. Okay. So now the very first part, what we're gonna do is we shall divide the equation 1 by AC square on both the sides, okay. Now we shall divide the AC square on both sides. Now what will going to happen, guys? Now AC square by AC square is equals to AB square by AC square plus BC square by AC square. This gets cancels out, so what you remain is 1. Now please look into it. Now if I suppose if I name it from the angle C, okay, so this is what I'm considering. So I'm taking it from the perspective of angle C. Now what is this AB square by AC square? AB is nothing but the opposite side of the angle C. So this is the opposite side and this is the adjacent side and this is the hypotenuse if I consider from the angle C. Okay, so now opposite by hypotenuse, which is nothing but sine square C, right? So if I consider the angle C, for angle C, AB is opposite and AC is hypotenuse, so it will become sine C. So since we have square, we'll name it as a sine square C. Okay, now what is this BC square by AC square? BC is nothing but adjacent side and this is nothing but a hypotenuse side, so which is nothing but cos square C. Look guys, have you got this point now? So this is our first identity. So since we have named it as sine square C plus cos square C is equals to 1, but on a general note, you can just write it as sine square theta plus cos square theta is equals to 1. Okay, so this is the general form and this is your very first identity, trigonometric identity. Okay, so please remember it is sine square theta plus cos square theta is equals to 1. Simple. I think you should, by this time I think these things looks very simple. Now do you remember the first equation? AC square is equals to AB square plus BC square. So this was our equation 1. Now instead of this dividing by AC, let's consider AB. So what we shall consider now? AB square. Now divide AB square on both sides. Now divide AB square on both the sides. Now what is going to happen, guys? AC square by AB square is equals to AB square by AB square plus BC square by AB square. This gets cancels out. This will become 1. Now what is AC square by AB square? Now we all know, I'll just draw a rough triangle here just for our, this was our C, this was our A and B, correct? Now what is AC by AB? AC by AB. So we know AB by AC is sine. Now this should be, guys, right? It is 1 by sine. So 1 by sine is nothing but what? Cosecant square, right? Cosecant square C is equals to 1 plus, now what is BC square by AB square? Adjacent by opposite, which is nothing but cot square C. Simple. So cot theta is nothing but adjacent by opposite. So the same thing, but instead of we have square. So this on a general term, how can we write it as? It is cosecant square theta is equals to 1 plus cot square theta. Right, guys? Look how simple it is. Correct? Are you getting it? Now we all know this theta should be whole square between, for all the values 0 degree, okay, greater than or equal to, but theta value should be always greater than or equal to 0 and less than or equal to 90 degree. So does it holds good for all the condition? Right, it should holds good for all the condition, right? Now we all know cosec 0 is nothing but infinity or not defined, correct? Cosec 0 is not defined, and as well as sine 0, it is also not defined, right? So even this identity holds good even for this situation or even for the condition where theta is 0 or equal to 0, correct? This is your second identity. Now let's move on to the third identity. Now the same thing, what was our first equation? AB square, just a moment. Now what was our first rule? AB square plus BC square is equals to AC square. This was our equation 1. Now first thing what we have done, we have divided by AC and we have divided by AB square, correct? Now which is the remaining? We shall divide by BC square on both the sides. Okay, now just check what we're gonna have. AB square by BC square plus BC square by BC square is equals to AC square by BC square. Now this gets cancels out. Now let me just write the rough sketch of the triangle. This was our C and this was A, B and C. Okay, now AB by BC, which is nothing but tan theta, right? So tan square C plus 1, since it gets divided. we'll be having 1. Now what is AC by BC? So BC by AC, we know it as cos, which is nothing but cos theta, adjacent by hypotenuse. But hypotenuse by adjacent is nothing but 1 by cos theta, which is nothing but secant square theta. Correct? You remember this, right? All the trigonometric identities or trigonometric, ratios, the definition. Look, if you know the definition, these are all very, very easy, guys. I'm telling you. You can just do the trigonometry just like this until unless you know the basics. So on a general term, how can I write this as? So tan square theta plus 1 is equals to secant square theta. This is our third identity. Now once again, this theta should be greater than or equal to 0 degree and less than or equal to 90 degree, right? We know that tan 90, if theta is equals to 90, then tan 90 is what? Not defined, right? Infinity. Look, even under this condition also the equation holds good, right? Even the secant 90 is also not defined because cos 90 is 0, secant 90 is 1 by 0, which is nothing but infinity or not defined. So even here also LHS and RHS both will be infinity itself, that is, it cannot be defined. So this identity also holds good for all the angles which is greater than or equal to 90 but less than or equal to greater than or equal to 0 and less than or equal to 90. So on a summary, so what are the equation we have done, which is sine square theta plus cos square theta is equals to 1 and 1 plus tan square theta is equals to secant square theta and 1 plus cot square theta is equals to cosecant square theta. So please make sure you remember all the three identities. Very, very important, guys. So if you know all these three identities, you can definitely go ahead with the problems. Okay. So in this session, we have just derived all the three identities, trigonometric identities. So in our next session, we're gonna dealing with the problems on trigonometric identities. Okay. So till then, make sure you like the video and subscribe to my channel so that you'll be notified with every new videos. So make sure you're pressing that bell button so that you'll be notified with every new video whatever we'll be updating on. So please make sure you follow the channel. Okay, so never forget to subscribe. Okay, so we'll be meeting on our next session. So till then, make sure you practice the sums, you practice the identities, and you revise it. If you know it, it's well and good. Please make sure you revise it. Okay, take care, bye bye, and stay safe.